This is 6.3, day 2, focusing on synthetic division. Yesterday we used long division. This is a different method of factoring out by an expression from another polynomial. So please write this example down. So we're going to use synthetic division to factor out x minus 5. With synthetic division, it's a little bit different than long division in the fact that you must only be able to factor out an expression that looks like this, x and then minus or plus some constant. If you have a bigger polynomial than that, let's say 3 terms or 4 terms, then you would have to use long division. The first step is to solve your blue expression for x. So right now it's x minus 5 equals 0. We want to solve that for x, so we want to undo it. So we would add 5 to both sides. So we get x equals 5. So now that's going to go over here, x equals 5. Now we're going to go ahead and make a box with some placeholders. And we're going to take the placeholders of the highest degree. So since it's a cubic, our placeholders are going to be x cubed, x squared, x, and then all the way down to the constant. Now we're just going to look at the coefficients. The coefficients of the x cubed term is 3. So that's going to be right underneath the x cubed. The coefficient of the x squared term is negative 17. So that's going to go right here. The coefficient of the x term is 15. And then the constant is negative 25, and that's going to go right there. Now here's where you may just want to put your pencils down and watch, and I'll give you some time afterwards to write it. So step 1, every single time you do synthetic division, you bring down this first term. Now what you do below this box is you multiply to this 5. So 3 times 5 is 15, and it's going to go right here. Now the columns we always add from here on out. So negative 17 plus 15 is negative 2. Now we multiply again. Negative 2 times 5 is negative 10. It goes right here. Now again, we add these two columns, or this column of two terms. 15 and negative 10 is 5. Now we multiply. 5 times 5 is 25. And then we add. Negative 25 plus 25 is 0. That number is the remainder if there is one. Remember when we did long division, sometimes we ended up with a remainder? So what we are left with is some values underneath this box. So we took out an x minus 5, so now we drop the degree. This is your x squared, this is your x, and this is your constant, and then your remainder. So go ahead and take a moment now and write up those values in your box. Now what you did is you factored out from the cubic the x minus 5. So what you're left with is 3x squared, that's right there, minus 2x, which is right here, and then plus 5, which is right there. You can also check the solution by evaluating the function for f of 5. If you substitute in 5 into the original function, you would get 0 as your remainder. Let's go on to the second example here. Since we just did one, this one you might want to just watch and see it again. Use synthetic division to factor out x minus 4 from 5x cubed minus 6x squared plus 8. So the first thing we do is we solve this equation for x. So x minus 4 equals 0. When we solve that for x, we add 4 to both sides. So that's what's going to go out in front. X equals 4. I'm going to go ahead and draw my box. And I look at my degree. My degree is a cubic function. So I have x cubed, x squared, x, and constant. Now I write the coefficients. The first coefficient is 5, so that goes under the x cubed term. The next coefficient is negative 6, so that goes under the x squared term. And then notice something that happens right there. We are missing the x term. So what we have to do is we have to put a 0 in for that placeholder. And then the constant is 8. Now we're set to do our synthetic division. So step 1 is bring down the 5. Remember what you do underneath the box is you multiply. So 5 times 4 is 20. Then we add. Negative 6 plus 20 is 14. And then we multiply. 14 times 4 is 56. Then we add 0 plus 56. And then we multiply. Times 4, 224. And then we add 232. What happened this time is now we have a remainder. So what this means is that x minus 4 is not factorable by its original cubic. Only when the remainder is 0 does it mean it's factorable. So now we started with x cubed. We drop it by a term. So now we're at x squared, x, constant, and remainder. So our answer then is 5x squared plus 14x plus 56, and then we have a remainder of 232. All right, this I don't want you to write down. This is what is called remainder theorem. You have a polynomial of some function, and you divide it out by x minus some constant. If the remainder is 0, is what it's saying, then you can divide it out and check using synthetic division. If the remainder is 0, then it is a factor of the polynomial. If you want more practice, you can go to this website. And stop the recording and we'll go on.